So it's not just somebody's preference to go do this. This is physics. The distance a signal can travel over a copper cable is inversely proportional to the bandwidth. So every time you double the bandwidth, you have to cut the distance in half. Today, the highest speed production systems in the world run at 200 gigabits per second per lane, just to give you an example. So at that bandwidth, the cable length is limited to roughly 2.5 meters. Now, by comparison, systems running at 100 gig could use about 5-meter cables. And the height of the rack is about 2 meters. So once you account for all the routing inside the rack, 2.5 meters is right at the limit. So when we move to 400 gig, we can no longer fully connect the rack with copper. So the wall is moving, and it's moving now. And going forward, even the connections within the rack will become optical, and the whole industry knows this is coming. So we've been preparing for this moment, not just Marvell, but the industry. And you see this in Taiwan, by the way, in the supply chain and the ramp up that's happening. The ramifications for this are actually enormous because each time the wall moves one step to the right, the number of connections that you have goes up by at least an order of magnitude. So it's creating this explosion in demand, as I mentioned, and the optical supply chain needs to scale up massively and be ready. But we've seen this movie before, okay? I mean, 20 years ago, and I remember this, when state-of-the-art was 10 gigabits per second inside the data center. It was 10 gig. And we used copper cables all across the data center. Optics back then was reserved for just very, very long distances. It was essentially like a telecom technology, but when the wall moved, the optics industry actually rose to the challenge. And today, all the hyperscale data centers in the world, they're all optically connected. And as we saw in that transition, it did require new solutions. You couldn't use the same power-hungry kind of telecom approach, which is where PAM4 came in. It was optimized for power, density, and reach, and requirements specifically tuned to inside the data center. And Marvell was one of the key innovators there. So we're about to see the same wave of innovation needed as optics moves inside the rack. And that's with a technology called co-packaged optics, or CPO.